All right, radical 13. Remember what we're trying to do here. We're trying to take this thing and simplify it, okay? And we said yesterday, as long as the number under the radical is not prime, chances are you can simplify it. Not always. So a number like radical 6 is not prime, but you cannot simplify it any further. But if it is prime, it is 100% already simplified. What kind of number is 13? Prime. It is prime. So radical 13 is already simplified, okay? As you are, if you struggle with this stuff, because my goal right now, obviously my hope is that you guys can multiply, which you demonstrate that you can. But if there's any time that you struggle with the factors, if I could type in, I'll just type in prime factorization of, let's say I type in 360. Like there are sites here that will tell me that prime factorization. They'll give me that factor tree. Okay. There are some. Yeah, it gives me that factor tree again. This is the one I was looking for. This site gives it to me written that way. So 2 to the third is 2 times 2 times 2. 3 squared is 3 times 3. You see those there. This day in history. So if you struggle, if they're really large numbers and struggle with making sure that your factor tree is correct, you can do a quick Google search. What about 15? Radical 15, is that prime? No, there are numbers that multiply to get 15 that are not just 1 and 15, right? So 3 and 5. Okay, now is 3 prime? Yes. Is 5 prime? Yes. So we stop with those. Those branches do not continue. Okay? So when we write our radical, remember what we said yesterday. We said if there are groups of like 3s, if there were 2 3s or if there were 2 5s, we would put that number out front. Are there any groups to go out front? No. So the things that don't have a group, they go back underneath, and they go back underneath with multiplication. So what's 3 times 5? 15. So radical 15, even though it wasn't prime, it is already simplified. Which means there is not a perfect square inside 15 as a factor that divides it. Okay? So we'll make that comparison here again in 20 then about that perfect square factor. If I look at 20, does 20, what are 2 numbers that divide to give me 20? 4 and 5. Did anybody think 10 and 2? Okay, so if I did 10 and 2, that's fine because those still multiply together to give me 20, right? Now if I'm back over here on this side, that's 4 and 5. Is 4 prime or composite? Composite, so what are 2 numbers that multiply together to give me 4? 2 and 2. What about 5? What kind of number is that? Prime. If I was over on this side, did it this way, what's that 10 going to break down to? 2 and 5. In both of these, do you have 2 2s and 1 5? So does that demonstrate that it doesn't matter how you break 20 down initially? And it doesn't matter, even if it was like 200, and I went 20 and 10, and then I broke down 20 as 4 and 5. If I would have gone 200 and gone 50 and 4, and then broke this 50, I never see maybe a 20 over here, right? Which is fine. When I get done with all these branches, I will still have the exact same factors. Okay? So here is a pair of 2s, right? So I write my radical. If there's a pair of numbers, then one of those pairs comes out. And then if the other things that don't have, the other prime numbers that don't have a pair, so 5 is the only one that doesn't have a pair, right? That goes underneath. So radical 20 is the same thing as 2 radical 5. Okay? So that set of numbers that I circled was 2 times 2 essentially, right? Which is 4, correct? You guys read that? What this means, when I simplify it like this as 2 radical 5, if you square that number out front, which gives you 4 in this case, that is the biggest perfect square that will divide 20. Okay? So think of my perfect squares that are smaller than 20. 1, 4, 9, and 16, right? 4 is the biggest of that group that will divide 20. Okay, divide it evenly. And that's the kind of nuts and bolts, or the kind of underlying concept of what we're trying to do here when we simplify a radical. Okay? Remember when we try to simplify a fraction, we're trying to find the value that divides both the numerator and the denominator evenly, right? Okay, so that's the underlying concept of simplifying a fraction. The underlying concept that's simplifying a radical is trying to find the largest perfect square that divides that 20 in this case. So here, same thing with 180. Okay, now the larger the number gets, okay, the more factors you're likely to have. Okay, and the larger this is, the more likely it's composite rather than prime. Not saying it couldn't be prime, but obviously if it ends in 0 or an even number, it's not going to be prime, right? Our prime numbers have to be odd. So what will, good.
So when it's a prime number, it's supposed to what's more, but pretty much
Okay, so 180, okay, what are two numbers that divide to give me 180? 18 and 10? What about 18? 9 and 2? What about 9? 3 and 3? And then 10 goes down to 5 and 2. Okay? So, writing my radical, okay, I have one group of 3s, right? So that can come out front. Do we have a group of 2s? We have a group of 2s? So 2 can come out front. Okay, now those, all the numbers that come out front will get multiplied by one another. Okay, all the numbers that stay on the inside, is there a number that should stay on the inside? 5 was the other prime number, right? Okay, so 5 should stay on the inside. Okay, some people prefer when they write their factor tree, like I like to, I'm just lazy, so I like to just circle them. But some people like to go 2 times 2 times 3 times 3 times 5, so that they can see the group of 2 a little bit easier. They can see the group of 3s a little bit easier. That's just personal preference, okay? But when I do this, now I get, what's 2 times 3? 6, so I get 6 radical 5, okay? Now, when we simplify, these things should be, if they are a simpler version, they should be equal in their amount. Okay, so these are just different formats. So if I question whether I've done something correctly or not, can I grab my calculator and simply type in square root of 180. Oh. Get that number right there. So that is the number that radical 180 is a symbol for. And then I type in 6 square root of 5. And since these decimal versions are the same, that tells me these two versions are the same. Does that kind of make sense on how you can check? Okay. So 315. Okay, like we were talking about, that will divide by 5, right? How many times does 5 go into 100? Goes into 120 times, so it goes into 360 times, right? And how many times does 5 go into 15? 3. So this gives me 5 times 63. Okay, what are two numbers that multiply together? Give me 63. 9 and 7. Okay, what's two numbers that multiply together? Give me 9. 3 and 3. So again, we've got 3 times 3 times 5 times 7, right? There's a group of 3s. So when I write my radical, one of those numbers comes out front. We usually say one of those numbers out of that pair comes out front, but really what's happening is that product there is 9, right? And the square root of that product is actually coming out front. So square root of 9 is 3. And then the 5 and the 7, they go back underneath, right? They don't have a pair. So it's 5 times 7? 35. So 3 radical 35 is a better version of radical 315. Is that okay? You guys do the last two on your own, and then we'll reconvene and talk about those. So radical 150 and radical 294. When you look at that 150, okay, I look at, so whenever it ends in 0, I always think I'll probably put 10. Because then it'll be those first two numbers, 15 and 10, as my two factors, and that just makes, I think, the process a little bit more efficient, quicker. So I get down to 2 times 3 times 5 times 5. Okay. Again, if you want to double check that, if you're uncertain about your factor tree, just take 2 times 3 times 5 times 5 and see if it gives you that 150. Okay. So I got a pair of 5s. So ultimately, that's a 25, and the square root of 25 can come out. And then 2 times 3, they don't have partners, so they go underneath. Does that kind of make sense? Another way of thinking about this, and we'll talk about this maybe a little bit more tomorrow, is that this radical 150 can be written as 25 times 6. Okay? And then if I write it as, so you write it that way. Now, we haven't talked too much why this would be the case, but I can rewrite this as that. And what kind of number is 25? No, prime. It's a special number that is almost like the antithesis of being prime. What two numbers can I multiply together? 5 times 5, right? So 25 is a perfect square, correct? And the square root of a perfect square is, in that case, 5, okay? So we know, like, 6 squared is 36, right? So the square root of 36 would be back to 6. 5 squared is 25, so square root back to, the square root of 25 goes back to 5. So I could think about 25 this way, as 5 squared underneath the radical. Does that make sense? And a power of 2 and a square root are inverses of one another. They undo each other. They're like addition and subtraction being inverses, or multiplication, division being inverses. So they just leave me with just 5. And that's where that 5 right there is actually coming from. Looking over here, that 294. So this is a situation where I get down to 147. I divide, it starts with a 4. So I divided by 1, or I divided by 2, and I got 147 right off the bat. So 147, to me, that's a weird number. It's a number I don't encounter a whole lot. And it's odd. So it's potentially prime. First thing I try, because of that 7, is to divide it by 7. Okay, so I took my calculator out, took 147 divided by 7. You don't necessarily need your calculator. How many times does 7 go into 14? 2. How many times does 7 go into 7? 1. So you can do that long division there if you wanted to. If I get 7 to 21, and that breaks down to 3 and 7. So then I got a pair of 7s here. So that 7 can come out front. And then again, you're left with 6 underneath. Is this something we can do? All right, you've got an assignment in Math Excel. I think it's 15 of these. Simply just working on that number underneath being a whole number. Tomorrow, we'll migrate to putting some variables under there, okay, and see how that works out.
Why did I hit you with that already? I don't even.